Recording. For those of you listening at home, hi Polly, hi Julia, hi Michael, and Dennis. Okay. We're going over worksheets 5E-4. Conversations are stopping. And I'm going to give you a respectable amount of time to finish this in class today. I just want to give you some hints as to how to finish, especially the intervals. People can sometimes get a little thrown by that. And number 5 and number 6, they're going to be very calculator dependent. Take out your calculators. I want to step you through a couple of techniques. This is an example not on the worksheet. I'm just going to get off the top of my head. What is the total distance traveled? And I think there might have been a typo in this thing. Yes. Oh dear. Yeah, there are two words that need to be fixed on number 5 and number 6 instructions. Grab a pen or pencil. Those of you watching at home, I hope you have a worksheet, grab a pen or pencil. I'll email it to you if you don't need it, or if you don't have it. Go on the back page where it says a particle moves along the horizontal line, blah, blah, blah. For problem number 5, problem number 6. Look at hint number 2. Hint number 2. Displacement is found by taking the integral of the velocity function, not the position function. Velocity function. I'll explain why in a minute. Blah, 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 blah. The rest is fine. Hint number 3. Total distance is found by taking the integral of the absolute value of the velocity function. Again, that was a cut and paste error that I did wrong. I just copied the entire line and pasted it, and the error came with it. So, everybody got those? In hint number 2 and hint number 3, should be velocity function, not position function. Okay. Howdy. No worries. So let me show you what I mean. In your notes, write this down. An integral. An integral is an accumulator. It adds up lots of tiny pieces. If you need to add up a huge number of very, very small things, an integral is designed to do that. In contrast, a derivative is a rate of change. If you want to know how fast something is changing, you take a derivative. If you want to add up a bunch of little values, you use an integral. Now, we used an example, I think, beginning of this week, end of last week. If you had a bathtub that was unplugged, let's say it's full of 100 gallons of water. I don't even know how much a normal tub does. But let's say it's 100 gallons of water to be easy. When you drain water, it doesn't drain at a constant rate. If it did, it would be easy to calculate. We could use algebra. If it drained at 1 gallon per minute, it's easy. It would be 100 minutes and the thing is drained. Does that make sense? But what if the rate at which it's draining changes? It becomes very, very hard to find out, like, okay, after 1 minute or after 5 minutes, how much water is still in there? Well, if the drainage remained constant, it's easy. After 1 minute, you drain 1 gallon. After 10 minutes, you drain 10 gallons. But what if it starts going slower? Which it actually does. In real life, the more water there is, the more gravity pressure there is, and the faster it goes through the drain. And as the water goes slower, 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 like if you have like a water cooler or something like that orange thingy over there, I noticed as the water gets lower and lower and lower, the water comes out slower and slower. It takes a longer time to fill up the glass or water bottle. Does that make sense? Because as they go further and further down, there's less water pressure because there's less weight because there's less water. And so it gets slower and slower and slower. For us calculus people, that makes things very complicated as far as saying, after 10 minutes, how much has leaked out? It's not 10 gallons. It's less than that because it started to slow down. And it's slowing down continuously. It doesn't go in jumps. If it went in jumps, it'd be easier. If it just, let's just say, it stays at 1 gallon per minute for the first minute, and then bonk, half a gallon per minute for the second minute, and then bonk. It doesn't do that. It glides down. So how are we supposed to find how much water is still left in there? It's pretty tricky. Total distance traveled is the integral of the absolute value of the velocity function. Why absolute value? Well, if you remember as I was walking back and forth in that example sometime in the last 2 weeks, when I'm walking forward, it registers as positive. So if I go 1, 2, 3 yards forward, and then all of a sudden I go backward, 1, 2, 3 yards backward. Displacement is how far I've changed from my starting point. If I go forward 3 steps and backward 3 steps, my displacement is 0, but my total distance is 6. Displacement cares about the sign. It's like +3 added to -3, and it becomes 0. Quick mental math thing. I'm going to move 4 times, and so I'll either go forward or backward. Clear? First, I'm going to ask for my displacement. I'm going to go forward 3 steps, backward 2 steps, forward 1 step, backward 2. What's my displacement? M&S? How would you calculate it? Like mathematically, what would you do? B.
You can move from 0 to 3,
Okay.
which is 3, and then subtract 2, which is 1,
Mm-hmm.
add 1, and then subtract 2 again.
Right. Treat the moving forward as positive numbers. This is 3. Then I went back 2. Treat that as negative. Then I went forward 1. Then I went back 2. So what is it? Is that? It's 0. My displacement is 0. You add them up. If they have positives and negatives, they may cancel each other out, and displacement likes that. Because displacement just cares about where I am. It doesn't care about how far I've gone. Now, is there a way, so this is displacement. How do you get total distance? You do this. It doesn't care if I'm going forward or backward, it just wants to know the value, the absolute value, literally. So this is 3 plus 2 plus 1 plus 2. Total distance. I just realized that DISP and DIST look a lot alike. Displacement.
Isn't it? Okay.
Oh, good. 4, 5, 6. Oops. Thank you. Yeah. Thank you. Saving my bacon. Does that make sense? When you use regular numbers and when you use absolute values? If you just want to keep track of how many steps you've taken, period, kind of like, what are the things when you walk that keeps track of how many steps you take? That's a technological one, but it's a pedometer. So it keeps track of how many steps you take. for help nuts and for people who are just entered numbers. So if you use regular numbers, it'll give you the displacement if you add them up. If you absolute value all of them, it'll give you the total distance you've traveled. That's exactly what's going to happen here. Not chatting too much. An integral is designed to add things up. By the way, this elongated s, I think I covered this about a month ago. It was very brief. Has anybody ever seen a copy of the actual Declaration of Independence? Like in a book, or maybe if you're in, did we see it when they're in the National Archives? Did we go to the National Archives this year? Or ever?
Yeah, I've seen it there. Just
Okay, yeah. They don't display it anymore because the light has been making the thing fade for 200 years. So they bring it out like once every 10 years, and they have special lighting in the room so that it doesn't let the ink fade. But this is the letter S, which in math is short for sum. Now in the Declaration of Independence, they did that. They used to elongate their interior S's, and just the first interior S. Don't ask me why. They just thought it looked cool, and it actually does. But this is pursuit, the pursuit of happiness. Life, liberty, and the pursuit of happiness. It looks like this. Calculus took that elongated S for sum, which means you're adding things up. So when I do this, I'm adding up all the little velocities, but I'm taking the absolute value of them. By the way, can somebody tell me what the absolute value of velocity is? Speed. Absolute value of velocity is speed. So the total distance traveled is the integral of the absolute value of velocity. So basically the integral of speed. If I want to take the displacement, it's the integral of regular v of t dt. Does that make sense? Now let's try this. Everybody look at problem number 5. That is the position function. S of t, again, I don't know why they do that. S of t is the position function. It's t to the third minus 14t squared. Grab your calculators. I want to show you a few extra things on the calculator as well that are kind of hidden. Go to the y equals screen, and can somebody remember what we're about to do? Grab my y. How do we use the y equals screen when we're playing with calculus, especially with particles moving on the x-axis?
We just plug in
Yeah.
all different ones, so we get all the
So which one goes where?
positions first.
Position is first in the y1. So go ahead and type that in. Use the letter x instead of t, because it doesn't know how to graph t. So it's x to the third minus 14x squared. Everybody good? What should I put in the next line? Like literally, what should I type? Max, help me out with y2.
3t squared minus.
Or we're going to use x. Yeah, so 3x squared.
Minus 28x.
Correct, minus 28x. Go ahead and type that into y2. How about y3? Jack?
6x minus 28.
6x minus 28, correct. What did you just do there? Like, what are these, John?
Position, velocity, acceleration.
Position, velocity, acceleration. Right. The original function, then the first derivative, then the second derivative. Okay. So if you ever need to refer to these, you've got them. Now, I do want to show you something that I have not shown you before. It's buried in the math menu. Go to the math menu. Scroll down below. You'll have to scroll down to number 8. What does it say? N deriv. This is the nth derivative. Basically, this will take any derivative you want. Go ahead and select it. Hopefully on the home screen. Oh, sorry. Is everybody still on the y equals screen? If you're on the y equals screen, quit out of it so you don't put the. If you put n deriv y equals screen, it'll freak out because it doesn't know how to graph that. So go on the home screen and then math 8. That's the end deriv. Now I have to remember this because I lost my manual. I'm trying to remember the order. I'm pretty sure it's kind of like the integral. It's formula, and then I don't know if that needs the variable or not. We'll try both ways, and if I get an error the first time, I'll give this second one. So nth derivative, basically we're going to specify what's the formula, and then what's the derivative you want. Is it the first derivative, second derivative, third derivative? You would just put 1, 2, or 3. Let's try this. Just for giggles, let's try something here.
I think it does require the variable.
I think it does. So try x to the third. Just type in x to the third. Then hit comma. Then I think you do need, huh?
Mr. Conlon, on ours, it shows up in some weird formula.
Oh, you actually have the, let me look, see what you have. I'm pretty sure that you have to, there's a slot for the formula? Yeah. A slot for the letter in front, and a slot for the number you're gonna plug in. If you have a new calculator, it looks like this. D over D something. In our case, it's gonna be dx. It's gonna be a formula here, or and then they have a bar here with something here. This is going to be the plug-in value. It cannot give us a formula, but it can evaluate the derivative at any value of x you want. So for example, I think you have to type in the formula first. I hope I'm right. So I'm just gonna do x cubed. And for people with an old calculator like mine, it'll say n deriv parentheses, and you put x cubed, comma. Then I think you need to put x. People with the fancy display calculator put the x here. Everybody else put comma x, then another comma, and then I'm gonna need to say what derivative it is, I think. I don't know whether to put the plug-in value or the derivative number first. We'll try it both ways. I want the first derivative plugging in 10. Because I want to plug in 10 here, and I want to get the first derivative. So, I think we have to do 1 comma 10. I hope this works.
So it should look like this.
Let me see, x cubed, x 1 comma 10, yes. Try it. Does anybody else have an old calculator? Max, do you have a new one or an old one?
I don't know. What does this count as?
Does,
I have that weird formula.
you got this? Then it's a newer calculator, yeah. It's got a newer operating system. What do you get?
300.000.
You got 300 point blah, 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 blah? What do you get?
103.
103, okay. I think we had the numbers backwards. Let me try this. 10 comma 1. That's better, yeah. So just for the people with old calculators, in deriv, it'll look like this. The formula, comma, the variable, comma, the x value, and then the number of the derivative. So the first derivative, second derivative, whatever. What do you get this time?
301.
301. Jack, what do you get?
I got 300 point something.
Give me the something.
Point 0, 0, 0, 0.
Was it 300 or 301?
Just 300.
300, really? Point what again?
5 zeros and a 1.
Max, what did you get?
300.0000000. That's 5 zeros and then 1.
Interesting. Something's funny about this. No, what did you get?
Well, the same as Jack and Max.
Same as all of them? What did you get? Same? Really interesting. That's really curious. Because the answer is supposed to be, well, I'll show you what we did. The first derivative is 3x squared. And if I plug in 10, I should get 300. I'm not sure why I'm getting the 301. Oh, hang on. Got it. Delete the comma 1 at the end. Did you get 300.0000 blah 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 1? So it should be x cubed comma x comma 10, and that's it. Yes. Everybody look up here. We went through this about 2.5 weeks ago. If you cannot recognize this, you'll be in serious trouble on the test if you're using this. What is this really? How many decimal places did I say you could trust the calculator to? 4. Round it to the 4th decimal place. What is it? Anyway. Yeah, 300. That's exactly the answer. This is calculator error.
The 1 is
Uh-huh.
what we would have rounded. Okay.
If you round it, if you kept the point 1, the 0.00001, it would be wrong. Not wrong by much, but it's wrong. This should not be there. The fact that this has a limited memory means that if it tries something really complicated, it can pick up some calculator error in the really, really small decimal places.
So if we put that on a test, like exactly what our calculator had.
I would take off points. Right. Because you need to be able to interpret. Basically, there are 2 times this will happen. Gentlemen, too loud. There are 2 times this happens. Derivatives and integrals. There may be a few other times that it'll have some goofy calculator error, but those are the 2 main culprits. What if I had 299.999998? Guess what it is? 300. Right. You have to know, when you're doing derivatives or integrals, you have to know to round to the 4th decimal place. Even if that does cost a little bit of error on our part, you'll almost always fix the calculator error that it gives you. Does that make sense? Okay. So if you needed to find a value of derivative, that's how to get it. So math 8 is derivatives, math 9 is integrals. So let's actually try to solve one of these answers. Someone, grab your worksheets if you haven't already. Let's look at number 5. We've got the t cubed, we've got all the formulas plugged in. The very first thing they're asking, find the maximum speed. Hint. Maximum speed is not the same as maximum velocity. So P. And guess why I called on you? Yes, exactly. But while you're at it, what is the difference between speed and velocity?
Well, speed is the absolute value of velocity.
Right, speed's the absolute value of velocity. So there are 2 ways to find maximum speed. And I did give you a hint in there. Hint number 1. Right. Let's talk that through. Let's pretend as I'm driving, my minimum velocity is -10. Like I'm going 10 miles per hour backwards, which is actually kind of stupid. And that my maximum velocity is 5. I'm creeping forward like in a parking lot, which makes it doubly stupid to go 10 miles per hour backwards. What's my maximum speed? My velocity went from -10 to +5. What's my maximum speed? Max. 10. How do you get that?
The absolute value of velocity.
Right. I gave you the minimum velocity and maximum velocity, and the maximum speed has to be one of those 2. Does that make sense? So look at number 5. How do you find well, in order to find maximum velocity or speed, you have to find maximum velocity first. How? Good.
Oh, sorry, I wasn't answering that. I just had a question.
Yeah.
That the function that we put into the n derivative formula, was that actually the answer for the total distance on this problem?
It wasn't, that was a totally random made up
Oh,
problem.
okay, yeah.
Yeah, sorry. That was just demoing how to use the function.
If you use that formula though and plugged in,
You can
formula
find
for
the
numbers.
derivative at any given value of x that way. So it might or might not be useful in any given
oh,
problem.
okay, I see.
Okay. But if you do, and it does come in handy every once in a while, how do you find the maximum velocity? What is velocity again? Julia Sean. How do you find the velocity formula? Derivative of the position. So the original function, take its derivative and get v of t. How do you get the max or min velocity? Let me talk this through. S of t is the position function. Tell you what, in your notes, write this. This is probably going to be important, and people could slip up on this if they don't know this. What happens when S of t equals 0? Physically, like what's happening in the real world when S of t is 0? We're talking about this particle that's moving back and forth on the x-axis. What physically happens when S of t is equal to 0? Can you describe in words what that means? So. Like what's S of t mean again?
Looks like the position on it.
Position. So what does that mean?
So it's like starting point.
Yeah, it's at position 0. The particle is at the 0 position. That's what it means. It says nothing about its velocity. It says nothing about its acceleration. It just says where the particle is. Does that make sense? Next question. What happens when v of t is equal to 0? That actually will have two answers. What's physically happening in the real world when v of t is equal to 0? Jack?
Wait,
What does that mean, first of all? What does v of t stand for?
the velocity?
Mm-hmm.
That's very
Right. What if it's equal to 0? What does that physically mean?
It's not moving.
Yeah, the particle is not moving. Gentlemen, I can start again. The particle isn't moving. And there's something else. It's not as easy to see. We got used to playing with graphs, not with physics. But I'll say this. You're at a maximum or minimum position. Remember, on a graph, when you set the first derivative equal to 0, it finds a maximum or minimum height. Now walk back a couple of weeks. F of x is height. F prime of x is slope. F double prime of x is concavity. When you set the first derivative equal to 0, you get a max or min from the previous formula. Let me say it again. When you set the first derivative equal to 0, you're finding a max or min of the original function. You're not finding a maximum velocity. You're finding a maximum height. When the velocity is 0, you'll find a max or min height. So tell me, how do you find a max or min velocity?
Find all the spots where it's equal to 0.
When what's equal to 0?
Velocity.
When the velocity is 0,
I mean, when the time is.
well, you're getting closer. What happens, here's the third question. What happens when a of t is equal to 0? There are actually three answers to this. What happens when a of t, first of all, what is a of t be? what does it stand for?
Acceleration.
Acceleration, right. It's how fast the speed is changing. What happens, like what's happening in the physical world when A of t is equal to 0?
Like it's just stopped. Acceleration is-
Well, think this through. Let's say here's a marker, it's moving. Now, let's just say, here's dead center. This is position 0. This is what happens when S of t is equal to 0. It's dead center. It might be moving. Let's just say you have a stopwatch or you have a freeze frame, you're about to take a photo. Let's say it's moving this way at like 10 miles per hour, and you go click, exactly at the center. S of t is equal to 0. V of t is not equal to 0. V of t is positive 10, because it's moving 10 miles per hour. If you're going backwards and you go click, S of t is 0 because it's dead center, but V of t is not 0, it's negative 10, because it's going backwards at 10 miles per hour. Does that kind of make sense? Acceleration, let's just say it's going 10 miles per hour, 10 miles per hour, 10 miles per hour, 10 miles per hour. Can somebody tell me the acceleration? Okay.
0.
It's 0. It's not speeding up and it's not slowing down. Positive acceleration means it's accelerating, speeding up. Negative acceleration means it's slowing down or being pulled the other way. So, what happens when A of t is equal to 0? What's going on in the real world, the physical world, in physics? Max?
Or like the velocity of
Yeah, the velocity is constant. The acceleration. Oh, by the way, does everybody have this thing written down? You're at a max or min position for the first one. I want to add a parentheses if it exists. There are some functions that don't have maxes or mins, like a horizontal line doesn't, for example. Diagonal line actually doesn't. So the velocity is constant when A of t is equal. Oh, sorry. Yeah, velocity is constant. There is no acceleration. I should have put that first. So it will not be changing speed anytime soon. But there's one other thing. Let me step you through this. When the first derivative is 0, you get a max of the original function. How about when the second derivative is 0? What? You get a max of the velocity function of the first derivative. So you're at a max or min velocity if it exists. Okay. I will add one last thing. We don't talk about it incredibly much. A prime of t. What happens when I take the derivative of acceleration? What do you get? Again, we don't talk about this much, and we're not. This is not going to be a regular question on the test. It might be an extra credit question, but it's called instantaneous acceleration. This is a measure of how fast is the acceleration changing. This is also called, this actually is a basis of a math, kind of an unkind math joke. It's called jerk. It's if somebody punches the accelerator and your neck gets snapped back, your neck gets jerked. That's instantaneous acceleration as just goose, it's now positive. Make sense? If instantaneous acceleration is negative, that means your head jerks forward. Okay? I understand that at UW-Madison, there was a math club or something like that, and they printed up T-shirts. This is basically the third derivative of the original function. they printed up a t-shirt that says, "I know you're a third derivative, but what am I?" This is like don't do that, by the way, it's unkind, but, and by the way, 0.01% of the people who are walking around the United States got that joke either. So, all the other math geeks would be walking around, yeah, good one. And they're, what? Never mind. Third derivative. What? By the way, don't do that. But, is third derivative ever useful? Yeah. If the third derivative, if a prime, we don't have a special letter for it. If a prime of t is 0, then you're at a max or min acceleration. If you ever need to find the maximum or minimum acceleration, you got to go one step further and take the derivative of the acceleration, set it equal to 0. To get a max or min of anything, take its derivative and set it equal to 0. If you want the maximum position, take the first derivative, set it equal to 0. If you want the maximum velocity, take the second derivative and set it equal to 0, and so on. Does that make sense? So there's a pattern going here. Number 5, the original question they're asking is, we want to find the maximum speed. Can't do that directly. It says it's either at a max or min velocity. You can do that. How? How do you find the max or min velocity? The original formula, can somebody read off the formula for number 5? I lost it. Josh, yeah.
Yeah, S of t equals t cubed minus 14t squared.
Good, thank you.
And then 4 is less than or equal to t, which is less than or equal to 14.
4 to 14. I'm going to do it in interval notation. It's the exact same thing. T goes from 4 to 14, including 4 and 14. So basically you're running this experiment from 4 seconds to 14 seconds. Somebody started the experiment and you don't start measuring until fourth second. And then you stop measuring at the 14th second. Make sense? Can somebody give me, it's already on the y equals screen, but can somebody do it for me off the top of your head? Jeff.
Sorry, what? Oh, 3t squared minus 28t.
And while you're at it, give me the acceleration.
It's 6t minus 28.
Right. How would you go about finding the maximum velocity? So when is the maximum velocity? What value of t gives you the maximum velocity? How do you find it? I'll say or min. How do you find a maximum velocity? Put together everything we've talked about this hour. Yeah. So what equals 0?
The velocity, or t.
If you set t equal to 0, that's at the very beginning of the experiment. That's actually before they started measuring. How do you get the maximum velocity? Here, look over here.
Oh, it's our maximum velocity acceleration equals 0.
Yes. Set a of t equal to 0. I want to see who remembers the pre-calc. I don't know if y'all have covered this yet. Does everybody have this in the notes? If you don't, may God have mercy on your soul, because you might not know how to do the rest of the worksheet. I think we're actually going to make the worksheet due tomorrow. Let's try this. 6t minus 28 equals 0. Solve. Shouldn't be that hard. No, go.
Add 28 to both sides.
Okay, so 6t equals 28.
And then divide by 6.
Okay. 28 over 6, which is better known as
14 over 3.
14 over 3. I don't often do this, but give me a mixed number.
Yeah. We could just put
4 2/3, correct. Is that on our interval? This is 4 2/3 seconds.
Yes.
It is.
Yes, it is. It's between 4 and 14. Does that make sense? So at 4 2/3 seconds, which is a little bit after we started measuring, it hit something, either a max or a min. Question. I want to find a max or min velocity. A quick example, which seems unrelated. It's not going to be this problem. I'm just going to make up an easy one off the top of my head. Find all extrema. We actually covered this in, I touched on it very, very briefly, first quarter. Find all extrema over the following. F of x equals x squared, comma, and x is going from -1 to 2. Now, whenever you clip things, this is way back when we did this during the limits chapter. We're trying to find a limit, and sometimes the only way to find a limit is to graph it. If the other methods don't work. The reason I'm doing this is whenever you clip things, it's a regular parabola, so it's over 1 up 1. The vertex is at 0, 0. And it goes up to 2, 4. Here's your graph. And that's it. Just use your eyeballs. Are there any maxes or mins in here? Heights wise. Do this each one. Give me one.
The minimum is at 0.
Yeah, the vertex, the minimum is at x equals 0. So the minimum value is at a height of 0. Any others? Max. Oh, by the way, see who remembers this. Is this a natural or artificial max? I mean minimum. Wow, that was stupid. Natural. This is natural. Smooth or non-smooth? Jack. This is a long time ago. What's that?
Non-smooth.
How would you figure?
Oh no, that one's smooth.
This one is smooth.
Oh, got it.
Local or let me see. Local or absolute?
Me?
Go for it. Actually, Pete, do this one. Is this a local minimum or an absolute minimum? It's absolute. Why do you say that?
It looks like the lowest point in the graph.
Correct, and it is. The lowest point in the graph ever. Now, if I had done this, this is a local minimum. This is an absolute. Everybody see why? Because this is the lowest point in that local area, but this is the lowest point ever. This is absolute. It's also a local one, I suppose. If you're a big shot in the world, you're also a big shot in your hometown. With all due respect to Jesus, who didn't get treated like that. Then a local min is just the lowest point in that general area. This is an absolute because it's the lowest point in the whole graph. Any other maxes or mins? No, give me one.
You have the point all the way to the right.
Okay. So describe it. Max or min, first of all.
So it's a max.
Maximum. Is it natural or artificial?
Artificial.
So, explain.
Because we clipped it, it's the border, so we could maybe guess keeps on going.
Right. Artificial maxes and mins are when you amputate parts. Whenever you it's called truncating. Whenever you clip off part of your graph, that's artificially making a max or min usually. Keep going. Is it smooth or non-smooth? Non-smooth, explain.
Well, it just completely cuts off on one side.
Yeah.
So it makes it not smooth.
One way to tell if it's smooth or non-smooth, pretend you're touching it with your hand. Would you bleed? If I go boink boink, I'm gonna like stab myself. This is non-smooth. If you had an absolute value graph with a sharp point, That would be non-smooth as well. It would be a natural non-smooth. This is an artificial non-smooth. Both of them make you bleed. Basically, non-smooth is you bleed. Keep going. Is it absolute or local?
Absolutely.
It's absolute. Because it's the highest point ever. John, give me the last one. Oh, sorry. This means that there's a maximum at x equals 2. What's the maximum value? Now when I say max or min on this graph, I'm talking about the max or min what? Slope? Concavity? The maximum or minimum what? Anybody? Yeah, height. This is a minimum height. This is a maximum height. I'm looking for a max or min height. So what's the maximum value here? Good. 4. The maximum value is 4 because we're looking at heights for max and min. It happens, it's sort of like, when does it happen? Write this down, please. When does this happen is a different question. At x equals 2. What's the value? What's the max or min? In this case, it's y equals 4. So there's two different questions. When a max or min happens is the x value. What the value of the max or min is the y value. Make sense? So, and then in this one, actually, Jonah, go ahead and do that. Max or min? Max. Natural or artificial? Artificial, correct. I'm going to abbreviate here. Smooth or non-smooth? Non-smooth. Absolute or local? Local, correct. Because it's not the highest point ever. So where does it occur?
X equals -1.
Yeah, it occurs where x equals -1. What is the value? What is it?
At y equals 1.
At y equals 1. Does that make sense? Everybody got this? I only have a few minutes left, so tune in. If I want to find, let's just say, over here. I wanted to find the maximum velocity. Can somebody graph this thing? It's a little challenging to graph, but you should be able to. Pretend that it is y equals, whoops, oh, for pity's sake, I think we're going to get invaded. X cubed minus 14x squared. Can somebody graph that for me? Let's say I just dump you in the middle of a deserted island saying I'm not going to rescue you until you solve this. And I'm not giving you any hints. Call on your pre-calc, I'm not really going to do that. Call on your pre-calc and calc knowledge and actually your algebra 2 and algebra 1 knowledge. How do you graph that thing? Yeah. You can factor it. Like how?
Well, an x squared.
Okay. What's left?
X1 is 13 equals 0.
What does that give you? Yeah.
It gives you the double root at x equals 0.
There's a root, whoops, at x equals 0, and that's a double root, and then what?
Another root at x equals 14.
Another root at x equals 14. Let's sketch this thing. Does anybody remember what a double root looks like? Julius, you show. What does a double root do? It bounces, correct. So there's a double root at x equals 0. 0 comma what? B. 0 comma 0. By definition, a root is the same as a what? X-intercept. Good. And then there's another one over at 14. Can anybody tell me what shape this thing's going to be? X cubed is 14x squared? Go, B.
Oh, it's gonna come down and then go back up and come back down again.
There's two possibilities. What degree is it?
2. No,
3.
3.
Degree's 3. It's called a cubic. So we have positive cubics and we have negative cubics. Which one is it? John.
Positive.
Positive, what do you say?
Because it has a positive height multiplier.
Right, the height multiplier is positive, so that's going to make it a positive. So it's going to be going up, then down, then up. Here, it's got to come from below, bounce, go back down, and then punch through. Question, how far are we supposed to go? We're not taking the entire graph. We're only going from what to what, Jack?
Sorry, I was totally zoned.
Okay? We're going from what to what? We're not taking the whole graph. Look at the original formula.
4 to 14.
From 4 to 14. Go over here. At 4, it's right around here. Can anybody tell me what interesting happens at 4 2/3?
Oh, the velocity
What?
stops.
Velocity stops. The velocity is 0, which means the slope is what? 0. That's here.
So it's like a saddle point, or whatever those things are called.
This is actually a min. This is actually a minimum point. So this part is just dotted. We're not going to worry about this. And this part is dotted. We're not gonna worry about it. Here's what I'm looking at. This is our graph from here to here. If you notice, I have 2 maxes, 1 min. Get that on your graph, on your paper, before I let you leave the room. If you don't have it, you will not know how to answer problem number 5.
If you interrupt Mr. Cochran,
If you assumed that 4 2/3 was the maximum velocity, that might or might not be true. We'll find out. But there are 2 other maxes and mins that are in the running. This has a velocity of, I don't know, it's something negative. This has a velocity of something else, I don't know what it is, it's negative. And this has a velocity of 0. I want to know which one has the highest speed. That means you have to take the absolute value of the height, and the height. That'll answer problem number 5 for that very first part of the question. Clear? We are out of time. So this might actually not be due tomorrow as well. So this might be due Monday. It's pretty thick. So no additional homework. Start working on this, see what you can do. Please stand. Be right with y'all. Let me pray. In the name of the Father, of the Son, and of the Holy Spirit. Amen. Glory be to the Father, and to the Son, and to the Holy Spirit. As it was in the beginning, is now, and ever shall be, world without end. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Okay, see y'all later.
Bye, Polly.
Thank
Bye,
you.
Julia. Bye, guys.
Okay, bye y'all. We'll see you later. Get healthy soon.